Hello students, hope you all are fine. In the last few classes we are discussing about full adder, half adder and binary adders as well as serial adder and parallel adders. We also discussed some drawbacks of serial adder as well as the benefits of parallel adder. Okay. So for today's session we are going to discuss some arithmetic operations of binary number. What type of arithmetic operations we can perform in binary numbers. Okay, basically in mathematics we have four type of binary operations, that is addition, subtraction, multiplication and division. So when we are discussing about the arithmetic operation, so one thing came into our mind, that is the decimal numbers. Okay, we can easily perform the arithmetic operation in decimal numbers, but it is quite different in case of binary numbers. Okay, so let's see the topics in detail. So binary arithmetic means, I said that it is the addition, subtraction, multiplication and division. Okay, so in binary arithmetic operation starts from the least significant bit, that is from the rightmost side. Okay, so this just a minute. So this is a binary number. Okay, here one question arises, that what is binary number? Basically the binary number having base 2. Okay, suppose I have a number 10. If I represent this number with base 2, that number is called binary number. Okay, so this one is a binary number which consists of zeros and ones. Okay, this bit is called, or this side is called LSB, that is the least significant bit, and this side is called MSB, that is the most significant bit. Okay, and whatever operation, that arithmetic operation is done, that performance or the operation started from this least significant bit position, right? Okay, so whatever addition, subtraction, multiplication, division, whatever operation we'll do in binary operation or binary numbers, then we start from this LSB. Okay, and you know that there is a signed and unsigned numbers in decimal value. When we we don't use any sign, any symbol, that is called unsigned number. If you use any sign, that is called signed number. For example, say for example, suppose 15. Okay, 15 is a decimal number. If I write 15, it means that it is a positive number. Okay, if I skip this plus symbol here, then also I can say it is a positive number. But if I want to represent this 15 in negative, then I must assign the value, or I must assign a sign, that is negative 15. Okay, when I use the sign, and this is the negative sign, then this number is called negative number. So this type of number is called signed number, because it is associated with the sign. This 15, I'm not talking about the plus value, this 15. Okay, this 15 is called the unsigned number. Okay, because here no sign is there. If we are not giving any sign, so it is considered as a positive number. Okay, if there is a sign, there is a negative sign, then it is called negative number. And uh, any number can be positive or negative. Okay, any number can be positive or negative. Again, I would like to repeat here, if any decimal number, any sign is not present, that is called unsigned decimal number. If there is a sign, that is called uh, signed decimal number. Similarly, in binary number also we have signed and unsigned binary numbers. Okay, basically for signed binary numbers, the MSB position or the MSB side, whatever bit is there, that bit can be recognized as whether the number is a positive number or a negative number. Okay, so here in this case, in this case, this is the binary number, as you know, because this number is consist of zeros and ones, and this side is LSB. This one is LSB, or this number started with this LSB side, and this position is called MSB. But this bit is called the sign bit. Okay, basically this bit is represent to sign bit. For example, say we have a number like 0 1 0 0 1 0. Okay, so this is the LSB side. Again, this bit is dedicated for the sign bit. Okay, so let's see in detail. Okay, so the n total bits, suppose we have a binary number which having n bit number. Okay, the total bit number is n. Out of this total n bit number, we have to divide it into two parts. One bit is for sign, and the remaining, that means n minus 1 bit, for the value which is a pure binary number. Okay, so n, again I am repeating here, n is my total number. Okay, here n is a total binary number. This case, this is the total n. Okay, so one bit is for sign bit, and we know that MSB position, at the MSB side, whatever bit is there, that is designated for the sign bit, or that is reserved for the sign bit. Okay, one bit, this bit is for sign bit, and whatever the remaining bit, that means if one bit is gone, then what are the remaining bits? That is the n minus 1. This bit is n minus 1. This is the actual value of this number. Okay, binary number. So this is the example here. Here I have an example. So 52 is a decimal number. If I convert this 52 into a binary number, then this is the binary number. It is the 8-bit binary number. Okay, 1 2 8-bit binary number. So this binary number, okay, this is the LSB, this is the MSB, and as the MSB said, that means it contains the 0, or the sign bit is 0. Okay, so it is a positive number. Okay, so this bit is dedicated for sign bit. Here I am writing SB for sign bit, and the remaining bit, that is n minus 1, it is the actual number, or say it is a magnitude of the number. Remember it, it is the magnitude of a number, magnitude of a binary number, m number. Okay, so similarly, this is the same decimal number, but this decimal number is a negative number. So this is sign bit, and the remaining are magnitude of this binary number. It is the actual binary number. So from this scenario, we got that if the sign bit is 0, the number is positive. If the sign bit is 1, that is the negative. Okay, the sign bit is 0, that is a positive. Okay, if it is 1, that is negative. Okay, clear? But there is some problem, there is some drawbacks. Okay, we cannot put that one at the MSB side and we say that it is the negative representation of that number. It is not possible. So for example, say I am taking a number 1 0 0 1. Okay, its a decimal value is 9. So I am taking this decimal value is 9. Somebody says that no, if I am taking this the sign bit, okay, the remaining number is 1, so it is in minus 1. Okay, this thing can be possible. Somebody say it is a 9. Okay, this is the 9, and somebody says no, it is minus 1, because this MSB is just taken as the sign bit. Okay, and the remaining value is considered as the magnitude number, as we just got the idea from this example. Clear? So this is not we cannot directly represent this sign bit as 1. Okay, so to represent the negative representation, we have to do the 2's complement form. It is represent the 2's complement form. Okay, so let's see what is the meaning of 2's complement form. Okay, so let's discuss about the 2's complement representation. 2's complement. Suppose I have a number 1 0 0 1. So the theory says that this is the sign bit, and if the sign bit is 1, the number is a negative number. If the sign bit is 0, that is the positive number. Okay, and if you are not thinking about the sign bit, then this number is the decimal value is 9. Okay, its decimal value is 9. So how we are going to represent this binary number in negative number? So we have to do the procedure. The follow is the 2's complement form. So before doing the 2's complement form, we have to do the 1's complement form. Okay, first we have to do the 1's complement form. After doing the 1's complement form, we have to add 1 bit at the LSB number, LSB side. In some cases, some carry will generate and the carry come back to this LSB side, but sometimes this happens. But the sure shot is that we have to add 1 bit at the LSB side of a 1's complement number. Okay, so 1's complement number means we have to flip each bit to its opposite number. Okay, suppose I have a number 0, the next number will be 1. Okay, if this is my 1 is my original number, the 1's complement form of this 0 will be 1. Okay, if my number is 1, the 1's complement of 1 is 0. Got it? That means it will flip to the next number. Okay, so similarly, if I want to make the 1's complement of this number, it becomes 1. Here is 1 is here, so it becomes 0. It is 1, so this is 1, this is 1, this is 1, and this becomes 0. Okay, I have to put 1 here. Now 1 1 1 1 1 and 0. This number is the 2's complement form. Okay, this is the 2's complement of 9. So this is the 1's complement value of 9. Okay, so here one problem arises here. So we are taking this 9 number is 1001. So here we are not putting the sign bit. We are not taking this as a sign bit. Okay, if you are taking it as a sign bit, the actual number is 001. Okay, here we are thinking that just I said this is a pure number. This we are not consider this is the sign bit. So we have to use a sign bit here. Okay, this becomes see, this is my number 1 0 0 1. That's it, 9. Okay, 9 number, and it is a plus 9 or positive 9. I have put a 0 here so that I can represent this value is a positive number. Okay, so now I convert this 0 1 0 0 1 to 1's complement form. It becomes 0 1 1 0 and 1. Okay, so it is the 1's complement form. And here if I want to add 1 at the LSB side, so when I add it, the result will be 1 1 1 0 and 1. So this is the negative of 9, minus 9. This number is represent negative of 9, and this number is the 2's complement number. Okay, this is the 2's complement number. So if you compare these two, what is the difference here? Why this procedure is completely wrong one? Here, if we consider this the sign bit, and we say that this number is a negative number, then this sign bit should be 1. It should not be 0. But this case, see, if you consider this the sign bit, the sign bit is 1 and the complete number is a negative number. Okay, so here one problem may arise, or a question may come. If we take this is a sign bit 1 and this number is magnitude value, and this is not 9, this becomes 7, then how can you say that it is a negative 9? But see, in the original case, we derived this number from this number. Okay, we derived this number from this number. So first we are taking the negative sign, sorry, positive 9, and from the positive 9 we are just doing some operation like 1's complement and 2's complement form, and whatever the result will there, that is called negative of that number. And from this main number, that is the source number, so if we consider this is the negative sorry, sign bit, and the remaining values, this remaining values is the magnitude of the number. See, the magnitude number is 9. Okay, so when it is converted into 2's complement form, we should not discuss about the magnitude of the number. Okay, so 2's complement form says that uh, when we are going to represent a negative of that number, then we have to do the 2's complement form. And in before coming to this 2's complement form, some are using the 1's complement form, but that is for the limited numbers, like up to 15 we cannot represent more than 15 numbers. Okay, 0 to 15 can be represented by using 1's complement form, and 16, 17, so it may create the problem. Okay, so this is the negative sign. Suppose say let's take another number. Okay, okay, let's take one number, that is 1 1 0 1. Okay, we take this number. So this is the binary number. We have to use 0 here, so that we can say that it is the positive binary number. Okay, so after that we have to convert it to 1's complement form. 1's complement form. Okay, this becomes 0, this becomes 1, this is 0, this is 0, this is 1. Okay, we have to add 1 at the LSB to this 1 complement form value. This is 1, this is 1, 0, 0 and 1, and this is a 2's complement value. Okay, 2's complement value, and 2's complement value represents the negative sign of this value. This is the 1's complement value. Okay, so just see what is the sign of this number, what is the sign of this original number. Say it is number A, and say this is a number B. Okay, so the sign of this A number is 0, so it is a positive number. The sign of this number is 1, so it is a negative number. So here we can say that A equals to minus of B. Okay, A cannot be, but A equals to minus of B. So any any number, if you want to make it a negative number, then we have to first put a sign bit there, or use a 0 at the MSB side of that number. Then after that we have to make a ones complement form. How ones complement form is done? By just flipping the bit position or bit values. Okay, after that we have to add 1 at the LSB of ones complement number, then we'll get the two's complement number, that is the negative of that number. Okay. Okay, I think you got a few idea about the sign and non-sign, what is the importance of sign or non-sign number, and how we use this sign number. Okay, how we got the sign number of a binary numbers. Okay, so let's do some operations, that four operation, that is the addition, subtraction, multiplication, and division. Okay, that is very easy. So let's see about the addition. For the binary addition or any addition, we need a two value. Okay, we need a two value, that is, let's say A and B. If we add these two value, then only our addition process complete and we'll get the result. We cannot add a single value. Okay, so let's say A contains some value, binary value, that is 1 and 0, and similar way B contains some value, that is 0 and 1. Okay, so A is a 2-bit binary number, B is a 2-bit binary number. Okay, we can add different bit numbers also, like for example, A is 2-bit number and B can be 1-bit or 3-bit or 4-bit number. The addition can be possible, there is no problem. Okay, if we add this two number, so as I said, or we discuss in the full adder and half adder, this is the first stage of addition, this is the second stage of addition. Okay, simply add 0 plus 1 is 1, and there is no carry, or the carry is 0. Okay, and next stage 1 0, it is 1. So see, this is the decimal value is 2 and this decimal value is 1, where when we add 2 plus 1, that becomes 3, the result is 3, so it is correct. Okay, so it means that if we add 1 plus 0, the result is 1 and no carry. Okay, if we add 0 plus 0, if we add 0 plus 0, then the result is 0 and there is no carry. Okay, if we add 0 plus 1, 0 plus 1, then the result is 1 but there is no carry. Okay, if we add 1 plus 1, the value is 1 and carry is 1, which we have already discussed in our last slides or last classes. Okay, in full adder and half adder. Clear? Suppose I have a number, say 1 1 0 sorry 1 1 1 0, and another number is 0 0, no, just make it is 1. This is 1 1 and 0. Okay, we have to add this two number. It is a 4-bit number, this is also a 4-bit number. This 0 plus 0 is 0 0, and 1 plus 1 is sum is 1, carry is 1, sum is 1, carry will move to the next stage. So here now 1, this is 0. Okay, sorry, it's my mistake, the sum is 0 here. Okay, carry is there, this is 0, the carry is 1. For this case 1 1 and 1, if we add 3 1, the sum is 1 and carry is 1, carry is 1. Okay, so now 1 and 1, that is sum is 0, carry is 1. So this is the carry, this is not the number, this is maybe we take it as A, we take it as B. When we add these two number, we are getting the result. In some results, we are getting the overflow condition. That time you have to discuss this MSB side. Okay. So see, again, let's check it. 0 plus 0 is 0. 1 plus 1 is 0. Carry is 1. 1 plus 1 plus 1. Okay. That value is sum is 1. Carry is 1. Carry goes to that. Then 1 plus 1, 0. Then 0 and 1. So this is the result. So binary addition is performed like this. Okay. This is very easy. Okay, next operation is binary subtraction, but here is one curiosity is that computer cannot perform the subtraction process, or there is no such circuit for the computer to do the subtraction. Okay, so computer do only addition, multiplication, and division. So the question is that how the computer do the subtraction. Okay, so just remember in mathematics, suppose subtraction of a number means I have two number A and B, that simpler number is A minus B. Okay, A minus B, clear? So in mathematics we know that A minus B can be written as A plus minus B. Okay, both are same. A minus B is same as A plus of minus B. So this is the negative representation of binary number, and we know that how to evaluate the negative representation of binary number just by using the 2's complement method. Okay, the 2's complement method. Say for example the number is A is 1 and 1, and I have another number B is 0 1. Okay, I have to do the subtraction. Okay, so here this value, this B value should be written as in 2's complement form. So here 0 1 is my value. Okay, so if I put 0 here, then it is a positive values. So if I put here and make it a 2's complement form, then this will be problem. Okay, so okay, let's do it. 0 1 and 1. Okay, this this is the 1's complement form, and we know that 1's complement form is the just flipping the numbers, then add 1 here at the LSB, then the final value is 1 1 and 1. Then we have to add 1 1. We have to put the extra 0 here. If you put extra 0, then there will no change about the original number. It just represent as a positive number. Okay, so now add this 1 1 and 1. This is nothing but this is the 2's complement form of 1. Okay, we add it. So this value is 1 and 1. We get 0 here. Okay, we get extra value is 1 here. Then 1 1 1. Value is 1. Carry is 1. 1 1. That value is 0. Carry is 1. So we are going to add the 3-bit number, but we are getting the 4-bit number. So it is overflow condition. So we have to remove this one, or we have to discard that MSB value. Then we are getting this value. This is our final answer. See the final answer. Here 3 is a positive number and 1 is the negative number. 3 minus 1, definitely we will get the positive 2. So we are getting the positive 2. We are consider this is the final number, final result. So this is my sign bit, and this is my magnitude of this number, and this number is 2. Okay, this is possible. This way the binary subtraction is doing. Okay, you take few examples, and if you have any doubt, then you talk to me. Okay. So next one is next operation is binary multiplication. Okay, in binary multiplication means if we multiply 0 and 0, the result is 0. If you want to 0 with 1, the result is 0. 1 with 1, 1 with 0, result is 0. 1 0, sorry. When we multiply 1 and 1, we will get the result 1. Okay, so here simply we have a number, this one, and this is my another numbers. Okay, so let's do the multiplication process. This one is multiplied with the whole numbers. Okay, this first is multiplied with this one. So 1 is multiplied with 1. This is the result is 1. Then 1 0 0, and we will get this one. Okay, then just shifting one bit position, then second bit is multiplied with this values, and will 4 zeros. Again 1 is multiplied with this number and will 4 zeros, and after that we have to add it. It is very simple. It's the same as the decimal way, decimal value multiplication process, same. Okay, we'll get the final result. Okay, just remember, in case of multiplication, all time it is 0 if any value is 0. Suppose this is my a value, this is my b value, any of the a or b is 0, the result is 0. Okay, any one of a or b or both are 0, then the result is 0. If both a and b are same, the result is 1. Okay, sorry, same means if a or b is 1, or a and b is 1, then the result is 1. Okay, okay. Binary division is another mathematical operation. The binary division is comprised of two binary arithmetic operation. One is multiplication and another is subtraction. Okay, so in last slide we saw how the multiplication is happening and how the subtraction is happening. During the subtraction we are doing the two's complement form, then only the subtraction is possible. And for computer there is no such subtraction circuit is there, only addition circuit is there. So we can do the subtraction by using the two's complement method. Suppose this is our main, this is the number, another number, we have to divide this with this number. Okay, so first one is multiply with this value. Okay, one is the first one is multiply with this number. Okay, right, this one is multiply with this number, and this is my number. Okay, so if we subtract, then I will get this one. So up to this 3 bit and this one, we have to subtract it. So what does it mean? 1 1 0, then this value will be the negative or the 2's complement form. It should be 2's complement form. So in sometimes we are not using that sign bit. Sometimes you can ignore the sign bit while you are doing the 2's complement form. Okay, that's okay if we ignore the sign bit, like this case I ignore the sign bit. Okay, while we are converting the two's complement form. After that we'll get this result. This result again, this 1 and 0 will drop here. Okay, this 1 and 0 will drop here. When this dropping is there, first we have to do the 0, put a 0 here, and we have to drop this 1 and 0. It is also same as the decimal process. Okay, then after that we have multiply it, and again again multiply with 1. Okay, again this value is here 1001. Then it is the subtraction process, and we have to make it 2's complement form. Then we'll do the addition, so we'll get the last value. If there is no drop operation is there or dropping value is there, then we have to stop it, and this is called reminder, and this one is the question. Okay, so this is the division process. And again I would like to repeat here, the division is comprised of two arithmetic operations. One is multiplication and the subtraction, and it is same as the decimal process. Okay, so thank you so much for the today's class. And you have to practice this lot, and whatever doubt you have, you can text me. or call me in my personal number. Okay, thank you so much.